Okay, let's do some extra practice with logarithmic differentiation. Students tend to have a lot of trouble with this. So anytime you've got anytime you've got your variable in the base and in an exponent, we're going to need logarithmic differentiation. See, this is the key. I cannot use power rule here. Power rule is when you have x raised to some constant power, then bring that power down, drop it down by 1. We all know this. That only works when this is just a number. If you have a variable up here, that won't work. This is also different than, say, we had a constant raised to a power. We can't use power rule here. This won't work. But we can, well, like we know this guy's antiderivative. The antiderivative of a to the x is a to the x. So 3 to the x times the natural log of whatever that number is. That's if the bottom is a constant raised to x. We don't have either of those scenarios here. We got our variable x as both the base and the exponent in all or most of these examples we're going to see. So we use logarithmic differentiation. We take the natural log of both sides. So ln of y equals ln of x to the x. Then we use rules of logs to write everybody down on ground level here. Bring all of our exponents down. So y. So rules of log say that x comes down to ground level. Then we use implicit differentiation. So we take the derivative with respect to x of both sides. The derivative of log of anything is 1 over that thing times the derivative of what's inside. This is implicit differentiation. Derivative of y is y prime. Over here on the other side, I've got a product. I'm going to have to use product rule. Derivative of the first times, leave the second alone, plus derivative of the second is just 1 over x times leave the first alone. I can clean this up a little bit. That's just natural log of x plus 1, 1 over x times x. This is who I'm trying to get by himself, so multiply that y over. So y prime will be y ln of x plus 1. So I'm multiplying into here. But I know what y is. It's this. Excuse me. So that's what we get. Right, here's a similar example. Take natural log of both sides. Again, we have a power raised to a power. So take the natural log of both sides. The entire point of taking logs, pretty much any time you take logs of both sides, you're trying to use the rules of logs. Mostly trying to get everybody down to ground level. So bring this sign down. Then take the derivative of both sides with respect to x. Derivative, you're getting the same thing every time here. Derivative of natural log of y is 1 over y times y prime. A lot of times you'll see people just write this as y prime over y. Same thing I did in the last one. Okay, now I have to use product rule here because I've got a product. Derivative of the first times leave the second alone plus derivative of the second times leave the first alone. Multiply the y over. I need these parentheses here. And maybe I'll write this guy here as sine of x all over x. And then I know what y is, so that's my last step pretty much every time is plug that back in. And then we circle our answer. Okay, now we can also use, oh, here, let's do this one. We'll get to some more complicated ones in a minute. Let's rewrite this guy as y. Notice my independent variable here is w. So we're going to take the natural log of both sides. And of course, like we need to be good with algebra, really, because we need no rules of logs. So this exponent will come down to ground level. We're particularly going to need rules of logs on the next example. Okay, now take the derivative with respect to w of both sides. So we're going to take dw. Derivative of natural log of y is 1 over y prime, or if you prefer, y prime over y. Now I've got two functions here. Derivative of the first with respect to w is 4. Leave the second one alone. Plus, the derivative of log of anything is 1 over that thing times the derivative of what's inside. The derivative of 3w minus 7 with respect to w is 3. So I pick up a 3 on top there, times the other guy. Remember, we're doing product rule here. So that'll be a 12w. So then multiply the y over. So cleaning this up a little bit, I think we get here 12w over 3w minus 7. And then fill in what y was. So once you get the hang of these, they're kind of fun. They're not too bad, but there is a learning curve here. And then we'll circle our final answer. Okay, now we can also use logarithmic differentiation to avoid doing a bunch of product rules and quotient rules. So I would have to use product rule twice here because I've got 3 functions and a whole bunch of chain rule. Logarithmic differentiation can make this a little easier. Maybe I'll make up another one where we can do quotient rule. So let's give this guy a name. Let's call this guy y. So we take the log of both sides. Natural log of y will be natural log of, I'm going to upload this document. So I am going to write out all these gory details here. Oh, that was to the 7th. Almost done goof there. Okay, now rules of log say things that are multiplied inside the log become added outside. So logarithmic differentiation turns product rule into sums and chain rule into constant multiples. So all of these guys are going to be added outside as logs, and all my little exponents are going to come down. So I'm kind of skipping a step here. Make sure you understand how I used rules of logs to get all this. That's just rules of logs. I haven't done any calculus yet. There's no calculus yet. Now I start doing calculus. Take the derivative with respect to t of both sides. Derivative, natural log of anything is 1 over that thing times the derivative of the inside. So we get y prime over y. And then here, like I don't have to use any product rule, no chain rule. Well, I do still have chain rule, but no product rules. So I'm going to get 8 from this 8. Derivative of log of anything is 1 over that thing. times the derivative of what's inside. So his derivative is another 8. I'm going to get a 64 on top there. That 7 comes along for the ride. I get 1 over the stuff inside times the derivative of the inside, which is just 3. I get a 3 over all this stuff times the derivative of what's inside, which will be in parentheses here, 18t minus sine of t. And we're almost done. Now we just multiply the y over. So y prime will be y times all of this, but remember what y was. So like it takes longer to write these out than it does to actually solve them. But this is still much quicker than if we had done product rule twice. Okay, so what do we get here? 64 over 18 minus 2 plus 21 over this guy. Almost done with this one. I'm not going to distribute there. And then circle this answer. Okay. Let's do one just a little bit uglier. We got a 1 over x there, but still I've got a power in, or I've got my x on the bottom and on top, in the base and in the exponent. We have to use logarithmic differentiation. We didn't have to here. We could have done this using a whole bunch of product rule. Here I have to. So take the log of both sides. Bring the power down. That's the entire point of taking logs. Take the derivative of both sides. Derivative of 1 or natural log of y is 1 over y times y prime, or y prime over y. Over here, I'm going to do product rule. Derivative of 1 over x, you should know, is negative 1 over x squared. So some side work here. X to the negative 1 power prime, just power rule. Bring down the exponent and then drop the exponent down by 1. Negative 1 minus 1 is negative 2. Times, leave the second guy alone. We're doing product rule here. Plus, derivative of the second guy will be 1 over 3x plus 5 times the derivative of the inside, so times 3 times the other guy. So let's clean that up maybe first. This will be negative log 3x plus 5 over x squared plus, and then we get, what do we get here? 3. I'm going to put the x in front. I need these parentheses. And now we multiply back through by y. May have to make this a little smaller. Okay, so then y prime, again, because I'm going to upload this, I want the complete solution here. Times all this stuff in a bunch of parentheses. And we'll circle our answer. Okay, it looks like I've got another example here. Just trying to do a whole bunch of examples. Take the log. We got x in the base and in the exponent. Take the log of both sides. The entire point of taking log of both sides is to bring the exponent down to ground level. If you try to do too many of these steps at once or in your head, you're going to mess it up. You just write out all the steps. Take the derivative of both sides. We haven't done any calculus yet. Now's where the calculus happens. So derivative with respect to x of everybody. You know what we get here, y prime over y. Got to do some product rule here. I'm going to get 3x squared. Leave the second guy alone. I want that to be obvious. That's not log times sine. That's log of sine. That is not product rule here. That's chain rule. Plus the derivative of log of anything, natural log of anything, is 1 over that thing times the derivative of what's inside. What's the derivative of sine? Cosine. And then because we were doing product rule, f prime g plus g prime f, I need this extra x cubed over here. That I'm going to write as cotangent. So we get y prime over y will be 3x squared times the log of sine plus cotangent of x times x cubed. And then we multiply the y back in. And what was y? That junk there. So that's sine of x raised to the x cubed times all this stuff here. And we circle answer. Okay, and then maybe for fun, let's do one more. Let's do one more. We can avoid quotient rule. So maybe y is okay, something like that. So I could do a whole bunch of quotient rule, chain rule, whatnot. I can avoid that by using logarithmic differentiation. I don't have to use it here because I don't have x in any of my exponents, but it does make it a little simpler sometimes. So we take the log of both sides. Now we got to remember rules of logs. Log of a fraction will be log of the top minus log of the bottom, and then I can pull these exponents out. So I'm going to get 5 natural log of the top, without the 5, obviously, minus 3 natural log of the bottom, without the 3, obviously, because we've pulled that down. So I did 2 different steps there. Log of a quotient is log of the top minus log of the bottom, and then I pulled the exponents down to ground level. Now we can take the log of both sides, or sorry, we can take the derivative with respect to x of both sides. We know what we get here. We get y prime over y. We need more space. Okay, derivative of log of anything. The 5's going to come along for the ride. Derivative natural log of anything is 1 over that thing plus the derivative of what was inside, which in this case will be 16x. 3 is going to come along for the ride. Derivative of log of anything is 1 over that thing times the derivative of what's inside, which will be 15x plus 8. And I'm not even going to bother distributing there. I will multiply those together. We'll get y equals, going to send the, or y prime, sorry, we'll get y prime equals, I'm going to multiply the y back over. So that was all of this. times, and then I need a big bracket here. Let's see, 5 times 16 is what, 80? Sure, I could probably factor a 2 out here and do a little canceling. Like maybe this would clean up a little bit, but that's not what we're trying to do at the moment. We're not trying to do algebra and simplify. We're just trying to get the calculus down. And that would be our final answer. Okay, now a couple of these problems I got from this source here. I literally just Googled logarithmic differentiation. I'll post this with this announcement. Like just Google that. You can find a bunch of practice. You need to practice these.